So let's talk a little bit more about the force of friction. So there's two different types of friction. There's static friction and kinetic friction. So static, which you've probably heard this word before, that means not moving or stationary. Kinetic means moving. So when we have the static friction and kinetic friction, we actually have two different forces for the same material and the same scenario. And the reason for this is that the coefficients for static and kinetic friction for the same materials are actually different. Now I have this picture on the right-hand side right here of these guys pushing this couch across the carpet. If you've ever done this before, you've probably noticed that it's harder to get that couch to start moving rather than to keep it moving. So what this tells us is that the coefficient of static friction, that mu s, is actually greater than the coefficient of kinetic friction. So looking at these equations, we actually can kind of write new equations for this. So our new equations look like this. We have the force of static friction is less than or equal to mu s, the coefficient of static friction, times the normal force. And then the force of kinetic friction is equal to the coefficient of kinetic friction, mu k, times the normal force. Now notice how we have this less than or equal to term for the force of static friction. So basically what this tells us is that that force of static friction is going to increase as your applied force increases until a maximum point. So we have a maximum force of static friction that we have to overcome in order for an object to start moving, but it's not always going to be that maximum force of static friction. Okay, so we can look at it in terms of graphing the friction force as we apply a force. That's what it says behind my little video, as force is applied. So what's happening here is we have a static region, which means that we're not moving. And then once we hit that threshold, we've applied enough force in order to get that thing to start moving, then we're going to be moving. So this Fs max up here, that's our maximum force of static friction. So that is when we have that mu s times the normal force. That's our maximum static friction. Now, under that, we can see that our force of static friction is increasing linearly. All right, so as my applied force increases, my force of static friction increases to that maximum point, which is why we had that less than or equal to on the last slide. So when our applied force is less than our maximum force of static friction, then the static friction force will equal the applied force until we overcome that static friction force. It doesn't make sense for the static friction force to be greater than the applied force, because then we'd have an unbalanced force in the direction of friction, and we can't have the object moving backwards because of friction, right? Does that make sense? So that's why our static friction force will equal the applied force until we get to that maximum point, okay? And then notice how when we get to this maximum force of static friction here and we overcome that force of static friction, the force of friction then drops down here to this moving region, which is our kinetic friction. And we know because mu k, our coefficient of kinetic friction, is less than mu s, our coefficient of static friction, that our force of kinetic friction is going to be less than our force of static friction.